In the previous section, we had discussed broadly about what are the concepts of risk and return, and how the decision making revolves around uncertainty, around the tenure of time, and how much investment returns a particular product is going to provide. And those decisions around the uncertainty that surrounds the returns on any investment have to now get classified or measured in the form of risk. So in this section, we are going to discuss about what is the preferred measure of risk in the financial domain, and how do we really calculate that measurement of risk, right? Now, broadly remember that in the context of broader financial management, any surprises are considered bad, right? This is any surprises are considered risk. Why is because your planning goes for a toss because of any of these surprises. So if you were expecting 20% profit and you ended up getting 10% profit, that's a downside risk where you made less than what you were expecting. And if you were expecting 20% but you ended up making 30%, that's an upside risk, right? Now, some of us may ask, why is upside risk a risk? If you make more profit, that's generally good. So intuitively, yes, that makes sense. If there is upside risk to anything, more is usually considered better, right? Having said that, in the context of management of businesses of work, if you are getting 30% profit, then there is something that was not anticipated upfront, that was not known upfront, and that's a surprise. So the problem is not so much with the extra profit that you got, but the problem is more with the surprise element in this entire context, right? So why did you have a surprise is what is more important than the fact that you had a surprise at all, or you had an upside or a downside surprise. So the concepts of financial management largely deal with eliminating any kind of surprise so that you try and take a decision making based on those parameters that are on your plate at any given point of time, right? And hence it is considered that both upside and downside risk are a part of surprises or are a part of uncertainty. Any uncertainty to your total premise is what is going to be considered as risk, right? So we'll try and quantify this risk, and we'll try and understand what this risk would essentially mean to us. Now, let's try and measure this risk somehow. Assume that the following scores were made by player 1 and player 2 in cricket, right? So player 1 scores 50, 50, 50, 50 across 4 innings. Player 2 scores 0, 100, 0, 100 across 4 innings. So if we were to calculate what is the average of these two players, in the first case, the average is going to be 50, 50, 50, 50. That's 200. 200 divided by 4 instances. So that's going to be 50. In the second case, also, your total run scored is 200 divided by 4. The average comes out as 50, right? So if you look at the average score of these players, that's exactly the same. Based on averages, if you are doing the selection, you are equally likely to select player 1 or player 2. Both of them would look or appear similar to you from your judgment point of view, right? But that's not the entire story. There is some sort of a deviation from the mean, right? So if I was to calculate the deviation from the average, in the first case, the player scores 50 every time, which means practically there is no deviation from the average. The average stays 50 and the player scores 50 every time, so there is really no deviation. In the second case, however, the player either scores 50 lesser or scores 50 higher. So any given point of time, if the player walks out to score runs, there is a deviation of 50, either plus or minus, right? So if I take an absolute value, a 50 run deviation is going to come every time, right? Now that that gives us more information about this player, more information about how do we go and look and understand what do we choose and what is the risk in choosing player 1 versus player 2, right? So That's what is the average of player 1, that's 50. The average of player 2 is 50. Variation in player 1 scoring is 0. He always scores the same as 50. Variation in player 2 is 50, either 50 more than the average or 50 less than the average, right? So either the score is 0 or the score is 100, any of the times, right? So now let's say we ask you to choose a player. Which player would you choose? Right? Some of us might say that we would like to choose player 1. And why would we want to choose player 1? Because the player 1 is consistent, there is a stable score, there is a view of predictability in the overall score that is being made. You can trust this guy to score average scores. Now, someone might say we would still want to choose player 2, right? Why? Is because there is a chance of upside, right? There is a chance of upside. There is an element of surprise here. And maybe we like that element of surprise. We may want to take that risk to get that extra 50 runs in one of the matches because that could be game changing, right? If you think about it, and if you look at the following of sport, there are a few players who are like this. They are selected purely because half the times they will not do anything, but the other half, when they really do something, that could change the game completely. That's possibly true for the player too. So this could be a game changing player. Either side, you take that risk on both the sides, right? Now, which player would you choose depends completely on what your outlook or objective is. If you want someone to play for your life, right, which is you want consistency, you want stability, it would have to be player 1. You don't want any surprises there. Upside, downside, everything is to be thrown out of window because you just want the surety that return is going to come there, right? If, however, you're looking for maximization of score, the probability that if the player clicks, you could win the match altogether or close the match there and then, you may be willing to take the risk and hence may choose player 2, right? Now just go back and try and change player 1 and player 2 with, let's say, investment 1 and investment 2. Investment 1 looks very similar to what fixed income instruments do. There is no surprise. They tell you that every year we're going to pay you 8 rupees on 100 rupees. And if you hold it to maturity, your return is largely fixed, right? Investment 2, on the other hand, is more like equities or stocks. You don't know where it'll go. It could give a higher return, but there is a risk of it giving you negative returns as well, right? Now, if your objective is that you want to secure a sacred goal. What is a sacred goal? A goal that you do not want to miss. For example, education. For example, retirement. In these cases, if you are playing for someone, if you're investing in order to get something as a stable source of income in your retirement time, you would want stability, you don't want surprises. If you get more, that's fine, but there's a bare minimum that you would want to kind of agree, and you don't want any negative surprises there. However, if you want to kind of try and get a vacation next year, right? And an international vacation next year, then in that case, you're looking at trying to maximize the returns that you are going to get. In terms of maximizing the returns, you would probably want to go for equities, right? So the decision making in terms of your calculations around this point is going to be based on what exactly are you trying to maximize, right? Are you trying to maximize the stability factor or are you trying to maximize the returns in this case? And hence this measure kind of falls in line with broader premise in financial